What's going on, everybody? It's Eric from Panola, and we're here covering another objective inside of our CompTIA Security Plus step-by-step objective video series. And today we're going to be covering objective 2.3, which is summarize the secure application development, deployment, and automation concepts. And this will be coming outside of our CompTIA Security Plus study guide, SY0-601. And we're going to be doing our best to do said summarize, and I think that's what we do best here on the channel. Now, definitely check out some of the other things that we do here on the channel, like and subscribe, follow, and do all that great stuff. And check out panola.edu for some of the other great courses that we have here, because some of the stuff that we're covering in these objectives are in tandem with our ITSY 1400 and 2400 courses, which we go more in depth in cybersecurity and work towards that associates in cybersecurity. And we cover other stuff like networking and intro to digital forensics. Now, first and foremost, we need to cover the SDLC, which is the software development lifecycle. And the biggest question we ask in all this is, how old is the software that we're using? And I'm looking at you Windows XP users. I know you're still out there. So am I. I'm right there with you. Solidarity. But are we patching those systems? Because in Windows XP, we can't really patch anymore because Microsoft doesn't offer any kind of support for those legacy operating systems. And so when we look at software development lifecycle, that's one of the things that we have to consider when we're creating our policy and how we address all of that updating that's needed on a regular basis. Now, Security Plus breaks this down into 8 areas of concentration, and we'll cover them very quickly. First of all is planning. And you can't do or execute anything without a great plan. So as we plan, we're talking about getting an idea of what systems we have in the organization to include the applications that are installed inside of those individual systems, such as like Microsoft Office, maybe even Adobe, as I'm using here to be able to record and edit some of this. What are we doing? And then once we got that planning out of the way, we're looking at the actual requirements of what's actually going on. So what are the requirements for Windows XP as far as keeping it inside of our life cycle? What about Adobe? What about all the other individual programs that we're using in order to be able to conduct business within our organization? And then we're going into design. Now, this is kind of if we're doing software development, but inside of the security world, especially looking at that enterprise organization level, design is more like how we're going to implement those said security patches. Are we utilizing a third-party software system to be able to push those patches out, or are we going to each individually and wasting a lot of time doing that? Not saying that's a bad thing in some cases, but if you're using stuff like SCCM or the new Intune for Microsoft, that's a solution. And there's other stuff out there too, like EPO from McAfee and all this other great stuff. And then we take a look at the actual coding of the software itself. Does the coding support what we're doing within the organization? And is that coding secure? Can it be injected? Can it be manipulated? Can it be used for any nefarious activity that we don't want it to be used for? Now, we'll touch more on that here in just a little bit. But that's where we start going into the testing world, because we don't necessarily want to throw a patch out right away unless we absolutely have to, something like a 0 day or something like that. We test what we're doing, and this is done in a sandbox environment, preferably, or maybe like an individual system that you have that mimics what's actually being used in production. And I say mimics because if you're using an individual system or sandbox type environment that doesn't necessarily match up with what's being used in the organization, whatever patches and stuff that software development that we're testing may not interact correctly when we actually go to do a real world implementation. And that goes along with the training and transition. So let's say for all you Windows XP users that we are trying to finally transition into Windows 10 and maybe even Windows 11. Well, if we're going from one operating system like XP to Windows 11, that's a big transition. So we might want to start looking at how we're going to train our staff into being able to use that new operating system. And that applies for other pieces of software as well too, and even hardware. Are we using external hardware hard drives, and are we using thumbsticks? Whereas before, we may be in the world of using floppy disk. Now, I know, but that does still exist out there. And that transition is something that we have to train our organization for. And then it turns into ongoing operations and maintenance. Yes, we've made that transition from Windows XP to Windows 11, but how are we making sure that maintenance is still taking place? Because now that we're on Windows 11, in our example here, we have patches, we have updates, we have things that are actively being supported by Microsoft because it's not end of life cycle yet. Well, we have to make sure that we're continuing our security due diligence in making sure that all of those applications are fully up to date, in compliance with our organization, and maintained on the hardware side as well too. Blow those fans out every now and then. Just little things like that. Now, after all of that, we go back to our Windows XP folks to pick on them a little bit, because now we're talking about end-of-life decommissioning. How do we get rid of all of those hardware and software solutions that we've transitioned from and get them out of our organization? And we can kind of go back to the beginning of all this, which is the planning, the requirements, the design, the coding, the testing, the training and transition, and the ongoing operations and maintenance to get to that end-of-life decommissioning. Because you don't just go in and yank it out. You have to make sure that everything is up to snuff before you do something like that within the organization. That's where we have to start getting with the C-suite upstairs. All those executive positions that start with the C, like the CEO, the CIO, the CISO, and all that great stuff, because they're the actual network owners. We are the security implementators. We're the ones that do it. So we do have to consider, is the lemon worth the squeeze here? And by that, I mean, is maintaining old hardware, software costing us more than if we actually upgrade it? Now, this is Security Plus, and yes, I get it. We should be focusing on the security, but we can't be secure if we can't pay for it. And that goes for the entire organization itself. Now, within Chapter 6, we do cover a little bit of material concerning about return on investment and little bitty things like that. That's where we start getting our introduction into it. Definitely worth a read. But the nickel and dime of this is that, yes, we may prefer to use Windows XP, but the cost of actually maintaining it and putting in security controls to make sure that not an obsolete, but an older, unsupported operating system, is it secure? Are we spending more money making sure that's secure than if we just went to Windows 11 and didn't have to implement all of that? Now, we talked a little bit about sandboxing a while ago and making sure that we are software testing correctly, and that goes into software security testing. See, while we're working on that SDLC, we always need to consider the practice of security testing. And so that's not just for patches and everything like that, but that may be that our organization lead comes up to us and says, hey, we need to implement a new piece of software that's not being used within our organization at all yet. So we go back to those 8 little points that we covered a while ago and start going through the whole cycle all over again in our sandbox testing environment to make sure that whatever we're about to implement inside of our organization is exactly good for us and secure. Now, certain things to consider when we're doing this is, can vulnerabilities be injected into the code of a program or inside of a running system or whatever the case may be? And if so, how can these injections be exploited? This goes into the pen testing side of the house, and when we're implementing new systems into the organization, during that testing phase, we have to make sure that we're stress testing enough to make sure that when it's in use and in production, that somebody can't just come in and do what we did in that stress test environment. Because if it can be injected, how is it being injected, and what vulnerability does it give them? Is it an authentication vulnerability where the manipulator has elevated rights and can pivot through the organization's systems and have unimpeded permissions on other systems? Or is it an authorization vulnerability where the attacker is just using stuff like malicious redirects to send people to other websites to do keyloggers, or just simply a server-side request forgery? SSRF. Yeah. See, we implement application security controls during this testing trial before we implement to the organization to try and prevent some of this. See, managing who can do what with what permissions is kind of key as to the application security control. One of the things that we can kind of implement for our application security control is input whitelisting. And this goes more into that application vulnerability stuff that we were just talking about. So are we managing what can be inputted and blocking things like 1 = 1? See, when you go to a website and it has an input box and you hit submit, let's say enter your email address to join this mailing list. Some folks can go in there and type 1 equals 1 and it dumps the entire SQL database, or begins to do that. But that's a known vulnerability for SQL injection. And that's something to consider if based on the application and based on the needs and all this other great stuff. See, we could also prevent users from inserting code into the URL. So like if you go to google.com and your web browser, you type in google.com/?equals, etc., etc. See, you may be trying to send a command to that web server to bring something back. Whereas if we do input validation and input whitelisting, we can prevent some of that and make sure that the user is not trying to exploit our systems, and all of our stuff is secure from the outer facing side as well. Now, if you've enjoyed this series, go ahead and like and subscribe, leave a comment below, let me know how I'm doing, and don't forget to check out the other great stuff at panola.edu. Again, we're just scratching the surface with the objectives that we're covering here. Don't forget that you can definitely come over to Panola online and join us for some of our classes in cybersecurity, networking, and digital forensics. I hope you like this, and I will see you in the next one.